So now that we've talked about the high-level view of the functional-based implementation of the FLApp case study that uses Spring WebMVC and synchronous code models and synchronous call models, let's go ahead and take a look at the flights package. And that's kind of the entry point, quite literally, because this is the application gateway or the front-end app gateway that takes incoming requests from clients and then maps them to the various microservice implementations in the flight listing app. And as we'll see, the requests are mapped to methods that will find all the available flights, find the best price for a flight request, get lists of airports, find departure dates for given pairs of airports, and so on. And it also plays the role of a Eureka client with respect to microservice discovery. So even though this is the app gateway in the server, it's actually a client from the point of view of Eureka. So this is essentially what's called server-side discovery. And you can see we've got a whole bunch of different properties here that are specified through annotations. We say this is a Spring Boot app. We say this is not a discovery client because it's the app gateway. We don't want it to be a discovery client. We'll see that the other microservices are discovery clients. We have an entity scan that tells it what to look for in order to find the various implementation objects, artifacts that are used to implement this application. And then we have property source, which tells where to go look to get the properties to configure this thing. And here are the properties that are set. You can see that the name of this thing is called Flight. It's the app gateway. This is really the name of this app. It's called App Gateway. I'm going to call it, it's kind of a microservice too, but we'll just call it a service. This is the port number that the Flight App Gateway listens on. It's the only port number that's explicitly defined. Everything else, all the other microservices have their port numbers assigned to them by the Eureka Discovery Service. We tell it where the Eureka Discovery Service can be found. We tell it to use IP addresses instead of host names. We tell it, don't register itself with Eureka because it's the app gateway. And we also tell it to cache information in the flight service so that it doesn't have to keep going back to the Eureka Discovery Service over and over again. It can cache it and reuse it from there. Okay, so that's what the flight application does. And you can see it does what pretty much every good Spring server or microservice does. It defines a main method and it says, hey, Spring, come and run me. It gives it the flight application class. And at that point, all the other dependency injection and other configuration related stuff all takes place when this particular server is booting up. Once it's up and running, it's offering this thing called a flight controller to clients if they know how to connect to it, which we will if they know the port number it's listening on and the IP address of the host. And this, of course, is the way that clients get into the FLApp functional service using Spring WebMVC. And essentially, it's handling GET requests synchronously via functional programming using Java streams and Java parallel streams. And again, basically, these are the capabilities it provides. This is really no different from the other implementations we've seen of application gateways, or even the monolithic application for that matter. This is a REST controller. It is going to have auto-wired fields. In particular, it has the flight service as its main auto-wired field. We'll see what that does in a second. And then it's got a bunch of methods that are essentially endpoint handler methods. These are the methods that are going to be used to take the incoming HTTP requests and convert them into calls to the implementation. So we have one that gets a list of all the airports by forwarding to the flight service. We have one that finds all the departure dates by forwarding to the flight service saying, here's a departure airport and arrival airport. Give me back a list of all the times when there are flights available so we could fill out a calendar, for example. We have a method called find flights, which takes the departure airport, the departure date, the arrival airport, and the currency. We want the price to be given in. Once again, we forwarded that to the flight service. Then we have another interesting method that I put in here just because it's really fun to implement, which is called find best price. And this will go and find the best price for a flight leg in our desired currency for our desired date. And it's going to do this by making calls out to the microservices and then doing some magic to kind of find out what the best price is using this clever algorithm we talked about last class, which we'll talk about in a second. So you can see that we put annotations to say these are all get mappings. And these, of course, are the parts of the URIs that are used to indicate that an incoming get request with the best-price URI will go to the find best price endpoint handler method we define here. So nothing particularly novel here. You can see that we put request param annotations on the parameters where needed. And that just indicates that these are parameters that are passed as part of the get request, and it's Spring's job to basically get that information out of the get request and invoke the method calls. And under the hood, of course, it's going to use some variant of Java reflection to do that lookup and those mapping steps. The heavy lifting, as always, is done in the service. So this is the thing that actually implements everything, that is defined, implements everything and more that was defined in the controller and the endpoint methods. There's at least implementations for every endpoint method plus other methods that are private methods to this particular file. And this implementation, as we'll soon see, uses Java sequential and parallel streams to make synchronous Spring WebMVC calls that will do all the various operations that we expect. Find available flights, find the best price for a flight, get the airports, find the dates, et cetera, et cetera. This class is defined as a service, and that allows Spring to do auto detection and wiring of dependent implementation classes using class path scanning, which it's going to get from the annotations that are put on the application, the flight application, using the scanning annotation there. And then there's also this thing called a discovery client, which we'll see down here, that's auto wired in. And that's what's used to be able to leverage Eureka so that calls to this flight app gateway are magically redispatched to the appropriate microservices, which run out in the cluster somewhere. Let's take a look at the flight service itself. We auto wire a REST template. If you come over here and you look at the components class, you can see that we have REST template, get REST template defined as a bean, as a load balanced bean, and it just makes a new REST template. And so when things are being connected together here, that particular REST template will be instantiated using the magic of dependency injection, and you don't have to write that constructor code yourself. Similar idea with Discovery Client, that's automatically created for you. There's another field called base URL. We use this here for mocking purposes for the tests, and it makes it easy to switch between the mocking version, which don't use separate processes, and the actual production version, which does. So here are the actual implementations of the methods that were, some of the methods that were defined in the controller class, the flight controller class. So you can see find flights. At this point, we're no longer dealing with the world of the HTTP syntax and semantics. We're now dealing with just good old native Java code or parts of Java's type system like strings and local date and so on. And find flights will call down to an implementation method, which will factor out code that's common between finding all the flights and finding the best price flights. And the way we differentiate this with our find flights impl is we pass in this parameter called flights, which will indicate which particular microservice we're going to call to, which in this particular case will be the one that's the airline, looks at all the airlines and finds all the airline flights that match, not just the best price ones. We also have another method called find best price flights, and that does the same thing. It calls find flights impl, except it passes in a different, basically passes in a different endpoint or operation, which is the one that's going to be best price. So it's going to call a different operation in the airline's microservice than the one up here. And you can see that the code is very, very similar, very common. So of course, we refactor that out into a common implementation method called find flights impl. So that's what both these methods call. Find flights impl does the heavy lifting. What it first does is it goes and it says, let me find all the airline services, all the microservices that handle airlines in this particular implementation. And you can see what it does is it uses the discovery client, which was auto-wired, and it knows how to talk to Eureka Discovery Service. And it says, hey, go find all the services that are registered with you. And that gives back a list of all the strings that were registered. We then convert that list into a stream, and we only allow strings or in the stream to continue on if they have the name airline in their name, like American Airline or Southwest Airline or whatever. So airline services are designated by their name, and we then collect those results into a list. So we end up basically with a list of these services, and then we convert that list into a stream. And look at that. So we get the list of strings, get the service here, and then we're going to go ahead and convert that list of services into a parallel stream. So for all the airline microservices, let's say that we had 8 different airlines. We had Southwest and American and United and Air France and British Airways and Nippon Air and whatever, whatever you have a lot of them. By using a parallel stream here, the requests to the different airline services to find the airline flights that might match will all be run in parallel. So that's the reason we're using a parallel stream here. And then we go ahead and we use the map intermediate operation on Java streams, parallel streams, and we go ahead and we make a separate URL for each of the airline services or microservices we're going to talk to. And make airline URL basically just goes ahead and creates the URL with the given airline, like American or Southwest or whatnot, the particular endpoint method we're calling it, we're looking for all the flights, we're looking for the best price flight. Then we go ahead and encode the departure airport and potentially the departure date, depending on which call is using this method, and then the arrival airport. So that's all made up into a nice URL. And that URL is then passed down using the magic of parallel streams to the next phase in the pipeline, which is another map call. So what we actually get back here is what's called the redirect get URL. It says what microservice to redirect to without having to hard code the port number and the IP address of that microservice's host computer. So we then go ahead and make a call to make get request, which is a method I wrote. I'll show you what it does in a second. Passing in the REST template, the redirect get URL that indicates where that microservice is running, and then the return type that we're expecting, which will be an array of flights. So let's go take a look at make get request. This is a helpful little generic method I wrote just to make my life easier because I reuse this all over the place in my implementation. And it uses the REST template. It calls get for entity, passes in the URL, passes in the class, which indicates what we want the return type to be. And then we basically get back an HTTP response object, and we get the body of this thing, which is going to come back as an object of type T, which in this particular case would be an array of flights. But as we'll see, it'll be different for different uses. We then go ahead and filter out any null arrays. If a microservice fails and we get back a null, we'll just filter it out. And then we do some really funky, cool things here. And this requires kind of a 6-degree black belt knowledge of Java streams and Java parallel streams. We use the map operation to convert each array into a stream. So remember, we've got basically a stream of arrays. And after calling this map call, we now have a stream of flight objects. So before we had a stream of arrays of flight objects, now we have a stream of streams of flight objects. And you might ask yourself the question, well, gosh, why don't we just use the flat map method there? And the reason for that is that flat map has this really weird quirk that says it serializes processing in a parallel stream for reasons that are quite a mystery. If I just saw the new Top Gun movie this weekend, and in the movie, one of the people, the Ed Harris's character, asks Maverick the question that we've all been wondering for the last 36 years. How does someone stay a captain in the Navy for 30 plus years? And Tom Cruise's answer is, it's one of life's mysteries, sir. And that's kind of the answer here, why we cannot use FLApp map. It's one of life's mysteries. And so to get around this particular quirk in parallel streams, instead what we do is we make ourselves a stream of streams, and then we reduce it using stream concat. And what that does is that we'll get the same effect of using FLApp map, in that we end up with a stream of flights instead of a stream of flights, but it doesn't incur the wrath of serialization. So it will still all run in parallel, and you get much better throughput, especially on a multi-core machine. So what we end up with here is a stream of flight objects for all the things that match the departing and arriving airports. We then collect those things into a map. And this is really cool too. We end up with a map that is grouped by the currency of each flight. So if you go and talk to Air France, they might give you results back in euros. If you go and talk to British Airways, they may give you back prices in pounds, British pounds. If you go to Nippon Air, they might give you back price in yen or whatever, whatever the different currencies might be. So we're going to group everything into a map where the key is the currency type: dollars, yen, renminbi, marks, I guess no more marks, euros, Swiss francs. And then all the values will be the list of all the airline flights that correspond to that particular currency. So we end up with a map that maps the currency to the list of flights. And then what we do is we have this really helpful method called try to convert currency. And it takes the currency we want everything to be in, and it takes the flights map, and it goes ahead and it does some magic to convert. And this itself is also some super cool functional programming. So I want to talk about it very quickly. So we take the flights map, turn it into a set of entries, key value pair entries, convert that set into a stream of key value pair entries. And then we use FLApp map because we're not worried about running in parallel here. If we were worried about running in parallel, we'd have to do the whole reduce stream concat trick again. But what we're going to do is for each of the different elements in the stream, we're going to convert the prices if necessary. And to do that, we use another helper method, which now takes the from currency and the to currency and the list of flights. And if the currencies are equal, we're done, nothing to convert. If they're not equal, then we go ahead and use another microservice call. So this is where we're able to reuse our make get request helper method from the utils class. So what we're going to do is we're going to go call out to the exchange rate microservice. And we're going to say for these things, go make a call to the exchange rate service and find out what the current exchange rate is from one currency to another. And assuming that that works properly, we get back a result that's not null. We then go ahead and convert the flights into a stream and then map them after first multiplying the price by the exchange rate. And so that'll make everything have a consistent price in whatever we want the currency of interest to be, whatever the desired currency is. If we want it in dollars or pounds or yen or renminbi or euros or whatever. So that's how we convert everything. And I think this is a really nice example of how we can kind of merge together functional programming with calls to microservices along the way. And there's another little helper method here that just goes ahead and makes the appropriate URL, knowing that we're using Eureka, so we don't have to encode IP addresses or host names or port numbers. And that goes ahead and does the exchange rate here, where we have exchange/rate, which are basically constants we define in the constants file. And then we put the from currency and the to currency in there. So when all of this is done, we're going to end up with returning a list of converted prices. And that is what comes back from this find flights impl method. We get a list of flights, and that is what gets returned back to the controller. And then the controller, of course, will package all that stuff up into JSON and send it back as an HTTP response back to the client. Just a couple more little things here. This is kind of cool. So here's the find best price implementation. This is another implementation of a controller method, which can find the best price. And you can see what it does is it calls find best price flights. And we saw that find best price flights just called to the flight simple. I could probably actually merge those two things. I'm not sure we actually need to have that as a separate call. And then we take back the list of best priced flights, which of course will be a subset of the list of all the flights. So that's why we want to use this call. And then we go through and we use that little algorithm we talked about a couple classes ago, where we find the minimum priced flight using the min operator in the stream. And then once we've found the minimum flight, we go ahead and use FLAP map in order to be able to essentially find all the flights that match the minimum if there's more than one. And when we're all done, we collect that stream into a list, and that's what gets returned. So this particular code uses that two-pass implementation that first finds the minimum price and then goes to the stream again and only takes out the stuff that matches the minimum, not assuming the stream is sorted, for example. So that's find best price. Find best price. Then there's a couple other methods here, one called find departure dates, where once again, we go and get the list of departure dates. I'm sorry, the list of airline services. In parallel, we go and ask all the airlines, what are your departure dates from this airport to that airport? Notice we put in null for the departure date parameter, and that is an indicator that we're not going to need it. We're looking up to find what the departure dates are. We don't know what they are. And what we get back here are then redirect URLs that we can pass along to the make get request helper method to go talk to the airport microservice, which we'll take a look at later. And much like what we did before, we filter anything out that comes back as null. And then we use our map reduce stream concat trick in order to be able to create a stream of local dates. We use the distinct intermediate operator in streams to remove any duplicates, because there's no need of having overlapping dates for things. And then we collect the local data objects into a list and return that. So once again, showing the power of streams, very canonicalized, very flexible, pushing a lot of the behavior into these helper methods that are called as behaviors. And then I think really the last method to look at here is called get airports. All it does is it just makes a call to the airports microservice, and that will come and give back all the information that we need about the airports. And if we get back an array of airports that's non-null, we turn it into a list and return that. Otherwise, we return an empty list. So I think that's basically this particular package. I think I've talked about all the stuff in there. Oh, here's the make airports URL. Very simple way of encoding that stuff. So that's the flight component. And that is essentially really the most important component in some sense. It's the one that plays the role of the app gateway. And it's kind of the master of ceremonies for all the other components.